Good morning, students. Yesterday we have done the MOT, molecular orbital theory, and the main points of MOT you have got when two atomic orbitals combine, they will form two molecular orbitals, and these two molecular orbital, one is called bonding molecular orbital and one is called anti-bonding molecular orbital. Bonding molecular orbital have lower energy than its corresponding anti-bonding molecular orbital. Now, when two atomic orbitals combine, suppose 1s combine with another 1s, why they form two molecular orbitals? Why one is called bonding, one is called anti-bonding? So that you can understand from this concept, formation of molecular orbitals. This formation of molecular orbitals, this can be explained on the basis of linear combination of atomic orbitals. Linear combination of atomic orbitals, and in short form it is also called LCAO, linear combination of atomic orbitals. What is LCAO? According to linear combination of atomic orbitals, when two atomic orbitals combine, then it forms two molecular orbitals. One is called bonding and one is called anti-bonding. So according to this, when two atomic orbitals combine, then it forms two molecular orbitals. Suppose this symbol is called psi symbol, already you have got in structure of atom. Suppose psi A and psi B represent the amplitude of wave. Amplitude of wave means wave function of the electron. Suppose psi A and psi B represent the amplitude of wave of the atomic orbitals of two atoms A and B. So psi A represent the amplitude of the wave for the atom A, and psi B represent the amplitude of the wave for atom B. So what is wave? As you know, electron, they have always wave nature. So the electron of A, it has one wave. Electron of B also, it has one wave. That wave amplitude is represented by psi A and psi B. The combination of the wave may be represent in two ways. So how the wave combine, you can represent it in two ways. I'll write the two waves in case 1 and case 2. So first time I'll write case 1. When two waves means wave of A atom, wave of B atom. When two waves are in same phase, what is same phase I'll give you later. I'll draw the diagram, then you can understand it. When two waves are in same phase, then they add up, addition will take place, and the amplitude of the new wave, phi is equal psi A plus psi B. This is case 1. When both the waves are in same phase, then combination takes place, they will add up, and the amplitude of the new wave phi, this symbol is called phi is equal psi A plus psi B. So this is case 1. And there is another way for the combination, which is said to be case 2. So I'll write now case 2. When the two waves are in opposite phase, then subtraction takes place, and the amplitude of the new wave phi is equal psi A minus psi B. So when the two waves combine, when the two atoms combine, then there are two types of combination takes place. When they are in same phase, then addition takes place, and when they are in out of phase, subtraction takes place. And that is why after combination, if addition takes place, then the new amplitude you will get phi is equal psi A plus psi B, and when subtraction takes place, phi is equal, you will get psi A minus psi B. Now I will show you. Suppose this is the wave for atom A, then the amplitude is represented by psi A, and this is the wave for B, and the amplitude is represented by psi B. See, their phases are same, they are in same phase. This is for case 1. When they combine, after combination, addition takes place, then the amplitude of the new wave will become double like this. And here the amplitude of the new wave, which is represented by phi is equal, you can write psi A plus psi B. So here addition takes place, and due to addition the wave become, the amplitude become double. But if the waves are in out of phase, for example, this is case 1. Now I will show you the case 2. This is the wave of A atom. Suppose it is like this. Amplitude is represented by psi A, and this is the wave of B atom. Its wave is like this, and this is the amplitude of the wave psi B. Here the waves are in out of phase, here they are in same phase, here they are in out of phase. So when they are in out of phase, after addition, after combination, what happened? Subtraction takes place, and the amplitude of the new wave you will get like this. Small amplitude you will get, and here phi is equal, you will get psi A minus psi b. I mean this amplitude minus this amplitude, you will get the resultant amplitude. A small amplitude you will get phi is equal psi a minus psi b. So when two atomic orbitals combine, when two atoms combine, then the wave, when they combine, they can combine in two ways, either due to addition or due to subtraction. That is why when two atomic orbitals combine, they form two molecular orbital. Due to addition, they will form the bonding molecular orbital, and due to subtraction, they will form anti-bonding molecular orbital. So that is why when 1s orbital combine with another 1s orbital, they will form the molecular orbital. But molecular orbital they can form due to addition also, due to subtraction also. Due to this addition, they will form bonding molecular orbital, and due to this subtraction, they will form anti-bonding molecular orbital. So now, and due to this reason, when two atomic orbitals combine, they always form two molecular orbitals. So now I will give you the name of molecular orbitals, what are the name of molecular orbitals, and how the addition subtraction takes place in orbitals.